I've been requested to do some more implicit differentiation or differentiation of implicit functions by, I believe his name is Akash. So I will do some more. And these are actually the problems that he sent to me, and they looked good. So those are the ones I'll do. So the first problem he gave me, and I'll do it in green, says, let's see, y to the third power minus x y squared plus cosine x y is equal to 2. So like all differentiation of implicit functions, and of course in these examples I'm going to, except for the last one, I'm going to find the derivative of y with respect to x. So in all of these I want to figure out what dy dx is equal to. Well, to do that, just like in the previous video, we just take the derivative with respect to x of both sides of this equation. So we do the derivative operator, I guess we could call it. So we're going to take it on this side, d dx, and we're going to take the derivative of everything. And then we're going to take the derivative on the right-hand side, the derivative of 2, which we know, hopefully, by this point is 0. And I'll do it a little bit quicker than I did in the last video, but anyway, send me a note if you think I did it too fast. So let's take the derivative of each of these terms. So the derivative with respect to x of y cubed. Well, it's the derivative with respect to y. We're just doing the chain rule. So it's 3y, that's a y, not a g, 3y squared. So the derivative of this function with respect to y times the derivative of y with respect to x. dy dx, that's just the chain rule. And then we have minus the derivative of this with respect to x. Well, this is a little interesting because here we have x times y squared, which we're arguing is maybe a function of, well, it's an implicit function of x. So how do we do that? Well, let me put the subtraction sign outside, and then let's do the derivative inside, and I'll do it inside some brackets. So let's do the product rule here, right? We have x times y squared. So the product rule says, it's the derivative of the first function times the second function plus the derivative of the second function times the first function. So the derivative of the first function with respect to x, right? Remember what we're taking the derivative with respect to. Well, the derivative of x is just 1, right? 1 times y squared plus the derivative of the second function. Well, what's the derivative of the second function? Well, it's going to be 2y dy dx, and that just comes from the chain rule, right? The derivative with respect to y times the derivative of y with respect to x. That's the chain rule. So that's the derivative of y squared, and then we multiply that times the first function, which is x times x, right? Hopefully that didn't confuse you. Just took derivative of x times y squared, this is the product rule, plus the derivative of y squared, which was this, times x. Okay, now we're ready to move on. Okay, plus, now this is interesting. This is interesting. We have to take the derivative of cosine of xy. Well, once again, we just do the chain rule. And maybe I'll actually break it out into a couple of steps here just so that you don't get completely confused. So what does the chain rule say? If we have, f of g of x of whatever, we essentially have to take the derivative of the inside function and multiply, or, well, I guess you could view it two ways. You could say we take the entire derivative with respect to whatever this function is. If g was equal to xy, we could say, the derivative of cosine of g with respect to g. And then we would multiply that times the derivative of this with respect to x. If that confuses you, I think it'll make more sense when I actually do the example. So this is going to be, actually, let me write it out like just the way I said it, because I think that could maybe even clear up some confusion over the chain rule, or maybe it will confuse you further. So what are we doing? We're going to do the derivative. Let me do this in a different color. So let's take the derivative of the outside function with respect to xy, right? So what is that? What's the derivative of cosine of x? Well, or what's the cosine? Let's say if it was g is equal to xy. If g is equal to xy, then that expression there is cosine of g, right? So what's the derivative of this with respect to g? Sorry, dg. Well, that's just minus sine of g, right? So let me do that in a different color. So it's minus sine, and g was just xy. So that's the derivative of, you can kind of say, of the outside function. And then we go to the inside, and we have to multiply this times the derivative of this inside function. Let me just write that like this: times the derivative with respect to x, that's what we're doing, of xy. And I'm going to leave it like that for now because that's going to take a little bit of space. And then that equals the derivative of 2 with respect to x. Well, 2 never changes, right? It's a constant, so its derivative is 0. So let's see if we can simplify this a little bit. And we'll come back. Actually, let me just, well, we'll come back to that. Let's just write this. Let's see. So we have 3g. No, I'm confusing myself with my bad penmanship. 3y. All that talk of g got me confused. dy dx. 3y squared dy dx. Minus, let's see, y squared. Minus, I'm just distributing the minus. Minus, well, let's see, xy. Minus 2xy. 2xy dy dx. Minus sine of xy. Minus sine of xy. And then this whole thing times the derivative of xy with respect to x. Well, we could just do the product rule here. What's the derivative of xy with respect to x? Well, the derivative of x is 1, so it's 1 times y, right? Derivative of the first times the second function, plus the derivative of the second function with respect to x. So what's the derivative of y with respect to x? Well, it's just dy dx, right? dy dx times the first function. That's just the product rule. Review the product rule if that was a little confusing. Is equal to 0. And now we can attempt to simplify. So let's see what I can do. So we have 3y squared dy dx minus y squared minus 2xy dy dx. Now this one's interesting. So let me distribute the sine of xy. Right? This is just a 1. So it's minus y sine of xy minus y sine of xy minus x dy dx sine of xy. I'm just simplifying. This is just algebra. Xy is equal to 0. Now let's group all of the terms that have a dy dx in them and distribute out the dy dx. So this is equal to dy dx times this 3y squared minus 2xy. I'm just undistributing, or I'm dividing out the dy dx, minus, so let me actually show you the terms. So this has a dy dx, this has a dy dx, and this is just algebra. This has a dy dx, so let me separate those out. So it's 3y squared minus 2xy minus x sine of xy minus sine of xy. Well, that's all of the ones with the dy dx on them. And then these terms, and I'm just skipping a couple of steps because this is just algebra right now. The non-dy dx terms, that term, and I guess there's only 2 of them. I'm just going to add to the other side of the equation. So I'm just going to bring them over to the other side. Hopefully that step doesn't confuse you. This is just algebraic simplification at this point. So that equals, I could have written minus y squared minus y sine xy and then added them on the other side, but I'm about to run out of space and time, so I'm just going to flip. I'm just going to add these to both sides of this equation. So that equals y squared plus y sine of xy. Right? I think I've covered all of the terms. And now, since our goal is to find the derivative of y with respect to x, we can divide both sides of this equation by this term right here. And our final answer is, the final answer, let me do it in a good color, dy dx, the derivative of y with respect to x, is equal to that y squared plus y sine of xy divided by this 3y squared minus 2xy minus x sine of xy. And there you have it. That was a good implicit differentiation problem. And if you understood how to do that, you understand how to do implicit differentiation. And I hope I didn't make any careless mistakes. And it's a good exercise for you to try to do it again on your own. See you soon.